Hi guys, welcome back. Today we're talking Algebra 1 in the third edition. We are on lesson 67. We're talking about systems of equations. I should write that on here. Systems of equations. Now, previously in lesson 59, we did it by substitution. Now I'm going to introduce it to you with elimination. So if you have any questions about that substitution, go back, watch that video and get some practice. But this is just a different way to solve these. All right, so what we're going to do here for elimination is, when I said substitution before, I was like, yeah, you have to write it side by side, right? Substitution means side by side. This case, you're going to be stacking these guys. I drew this little thing here because that's usually what indicates it's a system of equation, this thing right here. But I'm going to go ahead and erase it for right now because it'll be easier when I'm pointing out what we need to do. Basically, we're going to stack these and we're going to add them. However, when we add them, we're trying to eliminate either the x's or the y's. And in order to do that, we would have to do the opposite, right? So if you have positive 3y, you're going to want negative 3y. If you have positive 14x, you're going to want negative 14x. Taking a look at this right here, I can see I have positive 4y here. All I need the opposite of positive 4y is negative 4y. If I multiply this by 4, I would be able to eliminate these. Of course, if I multiply that by 4, I have to multiply the entire thing. So when you write your problem down, you write it down like it is in the book, and then you do any multiplication that you need to do. So this 4 needs to be distributed to all my chunks. So I get 8x minus 4y equals 52. Now, I am notorious. In fact, I was just working with a different student last week. I always forget to distribute this all the way over to here. I bet you will make the same mistake, but you'll probably see that mistake as I'm filming these videos. Okay, so I've done that. Now, I don't have to do anything down here because 4y and negative 4y and positive 4y will just eliminate. So we got 3x plus 4y equals 3. I'm just going to leave it just like it is. Draw a line, add. Yes, you're always adding. You can subtract, but it's way more complicated. You don't want to do that. Just always add. These guys cancel out because negative 4 plus positive 4. 8 and 3 will give me 11x equals, looks like 55 there. Divide both sides by 11. I get x equals 5. But remember, with systems of equations, you're not done. You got to find both your x and your y. So now what you want to do is pick either this equation or either the top or the bottom equation, and you're going to substitute in x. I'm just going to pick the top one out of, I don't know why, because I feel like it. So in fact, what I'll do is I'll rewrite it here so you see 2x minus y equals 13. Okay, so I'm picking that top equation. I'm going to plug that 5 in. So 5 minus y equals 13. 10 minus y equals 13 minus 10 minus 10. Negative y equals 3, which means if I divide both sides by negative 1, I get y equals negative 3. So my answer is, remember, we write this as an ordered pair, so it's going to be 5 with your x always first, x, and then our y is negative 3. That is our answer there. Okay, so elimination, again, you just need to multiply things until you can eliminate. That's all there is to it. Let's take a look at this second one. Now, you can eliminate either the x's or the y's. There's no wrong answer here on that. I'm going to choose to eliminate the y's here because, actually, I wrote this down earlier. Oh no, they want us to eliminate the y's next. So we're going to eliminate the x first. So 2 and 3, I'm going to end up having to multiply both of those. You want to think about like least common multiple, like if you were dealing with fractions. The least common multiple we would have for those would be 6. So again, I'm going to erase this just so I have some space here. So I'm going to multiply this by 3. And I'm going to multiply all the chunks. So I get 6x minus 9y equals 15. Now, the opposite of positive 6 is negative 6. So what do I need to multiply this guy by? Negative 2. So you got to be real careful with your signs there. If I do that, I get negative 6x minus 8y equals, I'm going to make a tiny little math error if I'm not careful. So 36. Okay, just making sure. Negative 2 times negative 18 is positive 36. All right, now we are in a position to eliminate because we have +6 and -6. So bam, get that out of the way. We are left with -17y equals. And if we did, okay, we got 51. And then, I don't know, my 17s, is that 3? Yeah, 3, okay. So now we can divide both sides by -17, -17, and we end up with, these cancel out, y equals -3. Again, you're gonna wanna grab either the first or the top or the bottom, one of those equations there, top or bottom. I'm gonna rewrite it, 2x minus 3y equals 5. The y is -3, so 2x minus 3 times -3 equals 5. I end up with 2x plus 9 equals 5, minus 9 from both sides. 2x, and this cancels out, 2x equals -4, divide by 2, x equals -2. So my solution set is -2, because we write it as an ordered pair, and -3, just like that. All right, you gotta make the noise, otherwise it doesn't work. Sorry, I should not move that so quickly. Okay, so let's see what else I've got here. Oh, right. Oh, so now we're going to do the same problem, but this time we're going to eliminate y. So let's go ahead and do that. In this case here, the signs are already different, so that's good. And I'm going to erase this so I can multiply. But we're going to need to multiply both the top and the bottom. Again, least common multiple is going to be 12 here. So I multiply this by 4, and then I multiply this guy by 3. Sorry about that. There's something under there. So if I do that, I'll just do this, yeah, that'll be thinking out loud. All right, so if I do this, I get 8x minus 12y equals 20, and then down here I get 9x plus 12y equals 18 times 30, 54, that's right, I literally just did that, 54, and then we're gonna add and do this. Those y's go away. We end up with 17x equals 74. Oh no, I dropped my sign. Do you see that? 3 times -18 is negative. So that is in fact not 74. So we end up with -34 divided by 17, divided by 17. X equals -2. Now I'm going to grab one of these ones up here. I'll start with that top one, 2. And instead of x, I'll skip a line so it's a little nicer. So I got 2. And instead of x, I'm going to put in -2. Make sure you're substituting the right variables in. That's a common mistake I see. Equals 5. So -4 minus 3y equals 5. That was terrible negative. Plus 4. Plus 4, I end up with -3y equals 9, divided by -3, divided by -3, y equals -3. So I end up with -2, -3. Okay, and if you go back and you look, it's the exact same problem. I just eliminated the y's first instead of the x's, and sure enough, we got the same answer. So it doesn't matter, you can eliminate either the y's or the x's. All right, so for example number 4. In this case, I'm gonna eliminate the y's because the words are hard. The signs are already different. So least common multiple for 5 and 4 would be 20. So I'm gonna multiply this by 4, multiply this by 5. So I end up with 8x plus 20y equals -28. I have not yet forgotten to distribute all the way over, but it's a fight. 15x minus 20y equals 5. Add, these cancel out. I'm left with 23x equals -23. Then divide both sides by 23, I get x equals -1. Plug it back into one of these guys. So I get 3 times -1. I'm using the second one here. So 3 times -1 minus 4y equals 1. So that's -3, right? So that's -3. So I'm going to add 3 to both sides. Kind of skipping a step here and there just to make it easier. So these guys cancel out. I get negative 4y equals 4. Divide both sides by negative 4. I get y equals negative 1. So my solution set is negative 1, negative 1. Bam. Okay. So let's do, all right, we're going to do these. So these are your 2 practice problems. Go ahead and pause the video, do those, come on back, and let's make sure that you know what you're doing. All right. So on this case, I'm going to eliminate the x's. So let's see if you get the same thing. In order for me to eliminate the x, my least common multiple is 6. So I need a positive 6 upstairs. So that gives me 6x plus 8y equals negative 14. And then downstairs, I'm going to do a negative 3 because a negative 3 times a positive 2 will give me negative 6x. This will give me negative 9y equals positive 18. Add. Cancel out. Negative y equals 4, which means y equals negative 4. All right, so y equals negative 4. I'm going to use this bottom one. I'm going to write it over here so I'm going to run out of room otherwise. 2x plus 3, and instead of y, I'm doing negative 4 equals negative 6. 2x minus 12 equals negative 6. Add 12 to both sides. I get 2x. These cancel out, equals 6, which means x equals 3. No, not 3. Yes, 3. Sorry. looking in different directions. Okay, so my solution is then parentheses 3, because I always put my x first, negative 4. 3, negative 4. All right, so box that. One more to go, guys. You guys are champs. Let's eliminate the y's this time. So I'm going to multiply this by 3 and this by negative 2, because if I'm eliminating the y's, 3 times 2 will give me 6. Negative 2 times positive 3 will give me negative 6, and then I'll be able to eliminate those. So 15x plus 6y equals negative 9. Negative 4x minus 6y equals 20. Add, draw the line, cancel out. 11x equals 11. X equals 1. All right, so let's plug it back in. I'm going to use that bottom one there. So 2, and instead of x, I'm going to put 1 plus 3y equals negative 10. Well, 2 times 1 is 2, so I'm going to subtract 2 from both sides. This cancels out, and I get 3y equals negative 12. Divide both sides, and I get y equals negative 4. So my answer for this guy is 1 comma negative 4. All right, guys, if you have any other questions, let me know. Otherwise, systems of equations with elimination, you have got it. All right, thanks, guys.